Welcome to my presentation on ocean acidification. So in this presentation, I'm going to be going over the different disciplines of oceanography and how they relate to ocean acidification. I will also be going over the effects of ocean acidification on our oceans and how we can prevent it. For physical oceanography, the ocean and the world's oceans are a giant mixing bowl of seawater. CO2 is dissolved into the ocean from the atmosphere and is being mixed around by currents and tides and waves all the time, just mixing all that CO2 around and lowering the pH levels. Through upwelling, seawater from the deep ocean is also brought up to the surface through currents, and this plays a huge effect on ocean acidification because the deep water, as you can see on this chart right here, is more acidic than the surface water. And bringing this acidic water up to the surface lowers the shallow water's pH that coral needs to survive. Next up, with geological oceanography and ocean acidification, we are able to see records of multiple of these events happening throughout Earth's history. We are able to observe trends with them, so how the ocean pH drops, then global temperatures rise, and with this, extinction events do follow, not just with marine mammals, but also land animals as well. And we are able to look at things like sediment cores and fossil records to show how these happen. Next, we have chemical oceanography, which is a big one with ocean acidification. Here I have a diagram of the process of ocean acidification and how we get the molecules that do lower the pH. So CO2 in the atmosphere is absorbed by the ocean almost like a big sponge, and then these molecules of CO2 react with the water molecules and create a weak acid that we know is carbonic acid. This acid then does break down into bicarbonate ions and hydrogen ions, and these hydrogen ions are the more acidic ones that do contribute to the pH level dropping. Now, some of the ways that the CO2 levels in the atmosphere have risen and what really contributes to ocean acidification are burning fossil fuels, which is mainly from car emissions, as well as deforestation, which means a lot of the plant life is lost that is able to take up the CO2 from the air, and these just lead to an increase in carbon CO2. Now for biological oceanography, I do just go over how ocean acidification has a huge effect on a lot of different marine organisms. So the shelled organisms of the ocean, those are going to be your crustaceans or your mollusks or creatures like that. They rely on hard shells to survive, both as protection from predators and some as their homes. Now, as the bicarbonate ions in the water bond to the excess hydrogen ions, there's less carbonate ions in the water that calcium-reliant organisms need. This means that their shells and their skeletons are weaker and more brittle and easier to break. And in some extreme cases, the pH in an area being too low leads to their shells and skeletons even beginning to dissolve. This also does happen to shark teeth. They are shown to weaken in strength and structure, even developing holes and cracks in their teeth, which does make it harder to attack and eat their prey. And while they are able to replace their teeth as well, it does take a lot of energy, which they wouldn't have if they can't eat super well. Now, seaweed is currently being studied with the hopes that it can reduce the acidification in the ocean. Seaweed is able to take in a lot of CO2 from the environment around it, and we are seeing this in a lot of things like oyster hatcheries or seaweed farms. Now, the effects of ocean acidification that we see do affect like fisheries, so the life cycle of fish is affected a lot. Their early stages especially, it can lead to high stress, the eggs failing to form or hatch correctly, and sometimes even death. Plankton populations are also declining a lot, and phytoplankton populations, which do cause effects on the food chain, causing an upset from the bottom up. Less plankton leads to less food for the next level, and then the next, and so on and so forth. And Also, we see toxic algal blooms popping up all over the coasts. Now, these also do affect humans a lot, causing health problems and illnesses, and it can affect the coastal economies as well. For potential solutions and ways to prevent it, we are able to reduce CO2 emissions by as simple as carpooling or driving electric cars. Sometimes does help. For reef restoration projects, we are working to restore the coral reefs that have been affected by ocean acidification. There's also a lot of conservation efforts out there for protecting reefs and these ecosystems. And nutrient runoff is also a big one. Reducing this will really help with ocean acidification because it's a lot of chemicals and a lot of toxins used by the agricultural industry. So raising awareness of this can help to put legislation in place that may place limits on chemicals like these that harm the environment. And just a fun one that I really like is the Monterey Bay Seafood Watch program. This just helps you eat sustainably in your everyday life and pick out which seafood is good at the time and which is to be avoided. Now, we went over physical, geological, chemical, and biological oceanography and what these mean with ocean acidification, and we went over how to prevent and repair the damage from ocean acidification as well. Thank you, and I hope this presentation has informed you of the risks and dangers of ocean acidification and has provided some helpful steps and information that you can ensure our oceans are healthy and beautiful for generations to come. And these are my sources I used.